Hey everyone, this is AngelDAO's submission for ETHGlobal's Web3 Jam. Our team is made up of me, Daniel Warwick, and Mayor Bank. We built DynaChess as a demonstration of how to dynamically change data stored on Ceramic with read and write logic on Fluence and a front end in React. Before I demonstrate, I want to give a quick overview of the technologies we used. So Ceramic leverages IPFS to create a decentralized open source platform for creating, hosting, and sharing streams of data. So as an example, in the context of chess, one could use Ceramic stream IDs to verify outcomes of games independently of the backend and front-end service provider. Or if the service provider for some reason crashes mid-game, another service provider could just port over the game in the same way of using stream IDs. Next, we have Fluence. Fluence is an open application platform that serves as an open runtime that everyone can run, contribute to, and benefit from. Developers can integrate easily and effectively share data and users and ship new features much faster than traditional applications. So for our app, Fluence acts as a backend for read and write logic to Ceramic. And this essentially can be easily accessed in other apps outside of our front end that find it useful. And soon, with Fluence's open runtime, we will be able to earn from usage of our business logic. And so in the same way that Ceramic essentially allows the data to be ported over to whoever has the stream ID, Fluence can essentially be accessed in the sense of the business logic by whoever has access to the peer that decides to host that business logic. So in a way, you can think about it like Ceramic is opening up access to the data and Fluence is opening up access to the logic. So I think it's important to point out here as well that in the true nature of a hackathon, this is our first time using these technologies. So the high level overview might leave out some details. So I do recommend that you look at the documentation and do some research on your own, as these technologies will potentially be very useful to you when building new applications in Web3. So to get into the demonstration of DynaChess, so DynaChess, to kind of explain how it's dynamic, basically this hash is representing where the data for this game is being stored on Ceramic. So later on I will show you how it's being stored. But yeah, this is essentially like what makes everything dynamic. So anyway, we'll make the first move. This move was just stored on Ceramic. So we'll go to the Explorer. I should mention here as well that there wasn't a Ceramic Clay Testnet Explorer, so we went ahead and just hosted one. So we took the mainnet one and forked it and just enabled the ability to do testnet. So if anyone wants to use it, go ahead. So anyway, for whatever reason, we didn't have time to really look into the source code of this front end. Some moves, it takes a while for the history to be updated. So yeah, for whatever reason, whenever you start a new tile document, it takes a while for the moves to be updated. So anyway, I'll show you in a minute. But just to confirm, you can see I refreshed. I still have the same hash, and it was able to load the state. So it is being stored. So anyway, I just made a second move, and okay, cool. So now you can see the different phases of the document's state. And yeah, so you can see the pawn move and the knight move. So yeah, that's basically dynamic metadata. So I'm going to show you some other cool features and stuff that we have in here as well. So I'm going to basically just store this game in my notes and start a new game. So as you can see, I just started a new game and I have a new hash. So I'm going to place some moves here and yeah, watch it all update. So, all right, I just made 4 moves. So we'll go here and still doesn't load it. It takes a while for these things to update. Like I said, the front end, I don't know what's going on for it, why it takes a while for it to cache or whatever. But anyway, just fiddle with it for a minute. Maybe make another move. Okay, so here we go. As you can see, all of the moves are ordered sequentially based on the move that was made on the chessboard. And I'll include the hashes to the demonstration video so that you can look at the history yourself, but you can also check the history of the document so you can see the phases of the state of the document as each move is placed. The array that is being stored will append new moves. So now I'm going to demonstrate loading a game. So this game, just kind of remember the board, I'm going to store it, and then I'm going to load our last game. And so, yeah. So cool, this was the last game we played, and we were able to load it and can confirm. So yeah, 2 moves, c4, then knight to f6. So yeah. So now we'll go back to the game we were just at. And boom, yeah, we're at the game. Let's go check the Explorer. So yeah, you can see all the moves there. And just to refresh and show you how I can pick up the state of a game. So yeah. So from a high level, what this all means is I can dynamically change the state of metadata that is stored in a hash on IPFS using Ceramic. So just like how NFTs use IPFS hashes to store JPEGs, you could use this hash as metadata to be stored on an NFT, and this demonstration shows how you can dynamically change that metadata for that NFT, whether it be gaming or another use case. So for the last part of this video, I just want to go over the code and show you how we're using Ceramic and Fluence. So to start, I want to show you how we're interacting with Fluence. So this is our Fluence node, and I'll quickly show you the peer ID and relay ID. So as you can see here, this is our peer ID and our relay ID. We use these within the app to connect to our node and essentially do all of the ceramic interactions. This file here is all of the code that our node is hosting, and where we do all of the ceramic interactions. So Fluence essentially facilitates all of the ceramic interaction in our application. So we have generate doc, save moves, and then read moves. You can see here, we create the title document by using the ceramic client, and we just put in some fake filler data to start. And then we have the save moves where we are loading the title document that we had created, and we update it using the JSON we pass in from the front end, which is just an array of chess moves. And then we have the read moves where we basically fetch the moves stored on the document using the stream ID, and we return that to the caller. So anyway, yeah, this is all that our node is hosting. So to kind of explain another unique thing about Fluence, this is Aqua. And this is what's actually being ran. So the JavaScript I just showed you, or the TypeScript rather, that is actually being compiled via Fluence.js, so that Aqua can interact with it and execute it. So yeah, I'll show you here. So yeah, you can see here where I'm actually passing the instance of the class so that the service can have references to the logic. I'll show you too where in the front end we're actually making this call. So just so you can see from the front end all the way to the Aqua backend. So yeah, in the use effect function, we're actually calling generate doc here. So this is where we're actually interacting with that Aqua backend in our JavaScript. So we will try to get the app hosted on a public domain so you can interact with the app yourself. Otherwise, all of this code is going to be in our public repo, so you can clone it and run it locally yourself, and also just use it as a template potentially for getting started with Fluence and Ceramic. We're also happy to answer any questions, or if you have any pull requests that you want to make to improve whatever. Happy to interact with anyone who's interested to talk about the application.